and just kind of ones that, little tips if I can help you in a direction here. And then again, that's what your 3 periods, 9th period for, etc. Whole shebang is due tomorrow. So corrections on everything, whether it was skipped or missed. We're going to correct it, and then we're going to try to get it right next time. So 76 here we said was pretty basic. Wanted acceleration, you're just taking the derivative on the calculator. Nobody should have missed that. Number 2, 77, sorry. We definitely said yesterday, I think we said we definitely have to split that integral. Okay? F of x deals with the picture, but 1 does not. So I have to split the integral. So right off the bat, and there's probably one of these on every test. Okay? We've got to catch splits. Okay, so right off the bat, I want to recognize that f of x is the picture, 1 is not the picture. I'm going to split the integral. This side you can integrate in 2 seconds, I would assume, and plug the bounds in. And this side, they give you all the information. They told you that each area has region is 2. And anything sitting below is going to be assigned a what value? Negative. So you have -2, +2, -2. Now obviously you can add those up and integrate this. But once you catch the split, very basic question. 78 I thought was real nice. Just a quick related rates. 79 is a nice limit. Let's see, 81. Okay, I can't stress enough, you need a game plan before the calculator's useful. And you're kind of just saying, what's the key calculus word? Okay, they want to know how many extrema. Again, extrema is plural for both maxes and mins. All right, that's my plural, maxes and mins, extrema, relative extrema. So to find a max or a min, again, it's calculus. You got to set the derivative equal to 0. When in doubt, if you don't know what to do on a calc exam, set the derivative equal to 0. So grab your calculator real quick, throw that in your y equals. But these are ones we never want to miss. All right, they already took the derivative for you, so there was literally nothing fancy to do except look at the screen. Once it's in there, I started on Zoom 6, of course, but it does contain the interval from 2 to 4, so just change your x window from 2 to 4. And then you can easily tell the number of maxes and mins. So it didn't specifically say a min, didn't specifically say a max. It's asking for all of them, plural, when f prime changes from a positive to a negative or a negative to a positive. And again, you should be able to graph that and easily tell how many extrema you're staring at. Any questions on that one? Again, I kind of had that in the super simple question bank. All right, 82. Okay. Says the rate of change of altitude. Let's underline that phrase. The rate of change of altitude of a hot air balloon is given by this. The second you see rate, they're giving you the what? Rate. Quick 4-letter word for the slope, the derivative. They're giving you the derivative. Okay, so r of t, even though it doesn't have a prime on it, they are giving you the derivative of altitude. That is what this says. The rate of change of altitude, the derivative of altitude, 4-letter word rate means derivative, is given by this. Which of the following expressions gives the change in altitude of the balloon when the altitude is decreasing? So first let's tackle this. This is the derivative of altitude. If I want the change in altitude, I clearly want to integrate. I want to get rid of the rate and integrate. And I'm integrating just r of t because r of t already is the derivative. So that should eliminate choices D and E. This is the derivative, it says. Okay, so you just have to read the words. The derivative of the altitude is given here. So I'm going to integrate just r of t to get that value. Now the question is, over what interval am I integrating? And it specifically says when the altitude is decreasing. So again, there's that key calculus word. A function is decreasing when the derivative is less than 0. Now, who did they happen to give us already? Again, this is the derivative. They gave you the derivative. So you're just throwing this in your calculator. Throw that in your y equals. And specifically look from 0 to 8. So we're graphing this function from 0 to 8, and we're looking for the time when it's decreasing. So we're looking to see when it's sitting where? Under the x-axis. And if you look at these choices, do either of them start at 0? I don't have mine graphed. And is your picture up there?
Yeah.
Can I steal your screen real quick? Oh yeah, that feels weird.
That's not right.
Oop, you got everybody in the exponent.
Oh.
Okay, so this function is decreasing between this number and this number when it's below the x-axis. And those are the bounds that they're asking me for. So whatever this number is to this number. And looking at the choices, I think we can narrow it down. These two say it starts at 0. Is that true? Clearly, no. It's starting at some decimal here, which is after 1. So I'm going to guess that's the 1.5 to the 3.5. Okay, but again, like in your write-up, you're going to draw a sketch. You're going to be very accurate about what you're saying. Just trying to give you some tidbits here. 83, I definitely had in the easy category. The formula's right there. Average velocity. Okay, the moment you see the word average, what formula should you have down? Perfect. 1 over b minus a, and then literally velocity. We're not guessing. They gave you velocity. Average the velocity. 84. So they have a pizza heated to a temperature of 350 degrees, and then they take it out of the oven and put it in a 75-degree room. The temperature of the pizza is changing at this rate. Okay, so again, they're giving you the derivative right here. And it's measured in Fahrenheit per minute. To the nearest degree. So what do I want my units to be at the end? Degrees. I want degrees Fahrenheit. So to the nearest degree, what is the temperature of the pizza at T equals 5? So if I want degrees Fahrenheit and I have Fahrenheit per minute, am I going forward and taking a derivative, or am I taking off something and integrating? Yeah, it's just a simple integral from 0 to 5. I'm at Fahrenheit per minute, and I just want Fahrenheit. I want to go backwards. So I should be integrating from 0 to 5. Now, the only catch is the pizza did start at what temperature? So it's going to start at 350, and then it's going to change whatever it does here. Okay? They're trying to mess with you a little bit by saying the room is 75 degrees. Nobody cares what the ambient temperature is because we're just talking about the pizza itself. So the pizza starts at 350 degrees, and then I have to figure out how many degrees it changed from those first 5 minutes. Okay. 85 I had in the super simple questions. Obviously, you want to draw a trapezoid. That goes over the picture, and a right Riemann sum that goes under the picture. And that's pretty elementary. You should play with that on your own. 86 was just a nice volume question. We just tackled volume. That should be fresh in our heads. I'm going to skip that one too. 87. So they give us this function, and here's, look for the key calculus word. What is the x-coordinate of the inflection point? So again, highlight the key calculus word and come up with a game plan. How do you have a point of inflection? What's our justification? Perfect. And they're asking about f, so f double prime changes signs. That's exactly what I'm looking for. So if they gave me a graph of f prime and I want f double prime, what am I going to look at on f prime to get f double prime? Yeah, exactly. This is just look at the slopes. Obviously in the whatever interval, they didn't give you an interval. So the whole function, just look at the slopes and see where they change. Okay, but it's really about identifying that key calculus term and justifying. 88, again, I thought was super easy. 1 over 4 minus 2 is just half. So a half of somebody's area has to come out to be 1. You can kind of go through and estimate each area. Pretty easy question. 89. Okay, equation of a line. So the first thing you should be saying is I need an x, I need a y, and I need a slope. And they're telling you the x value is 2. Now, they're asking about function g. How do you get a y value if you know x? Simply plug it in. Plug in 2 and you get your y value. How do you get a slope in calculus? Take the derivative of g. And again, make sure you're doing it of g. They're asking about g. What rule do I need to use to take the derivative of g here? Product, because it says x times f of x. Okay? And once you get those 3 values, throw them in the equation of a line. You didn't even have to like clean it up or anything. But that was a nice simple question, I thought. They give you x, find the y, find the slope. 90 is another question that's on almost every exam. A lot of times it's in the calculator. No calculators needed whatsoever. Just got to read it. It says the first derivative is positive. Positive first derivative. What would my function be doing if the first derivative is positive? Increasing. So let's narrow some choices out. Which of these is not increasing? Who can I eliminate? C is out. D. E. I mean, right off the bat, that would have been like a 50-50. So, I mean, it's definitely one you should have tackled. And now the second derivative is negative. So my slopes are, what it's saying is we're increasing, because the first derivative is positive, at a decreasing rate. We know we're increasing because the slope is positive, but the rates have to be decreasing. So all I have to do is find those slopes between these 2 points. Okay, we did a whole, I was just going through the calc book trying to make some little reference sheets. I mean, we spent like 2 days just doing these tables, just because it's always asked. So change in y over change in x. 9 minus 7 all over 3 minus 2 should get me a slope of 2, f prime. 12 minus 9 over 4 minus 3 looks like a slope of 3. 16 minus 12 over 5 minus 4 is a slope of 4. So obviously, these slopes are positive, which tells me the function's increasing, but what are the slopes doing? Increasing. So this would be increasing at an increasing rate. Okay, let's just verify this one. 11 minus 7 over 3 minus 2 is a slope of 4. 14 minus 11 over 4 minus 1 is a slope of 3. 16 minus 14 over 5 minus 4 is a slope of 2. So these are increasing because the slope was positive, but now the rates are getting smaller. So this is increasing at a decreasing rate. Okay? And again, you're going to see that on every exam. That's a very, very common question to go through. Let's see what else jumps out at me here. 91. Again, on every single exam. Particle moves along the x-axis, so they're given the acceleration. If the velocity is 2 at 1, highlight that. Right off the bat, initial condition. It's definitely a want question. It's a want initial condition. What is the velocity at 2? So I want v of 2. Set up an equation for yourself. Want equals initial plus initial to want. These questions are not going away. They're on everything. Okay, so again, I'm just going to call it a want question. We spent days upon days writing these want equations. I want equals initial plus initial to want. So I want v of 2, so I'm going to start with v of what number? V of 1 plus, remember these are always the same. This is going to go from 1 to 2. If I want velocity, I should be integrating acceleration. And bam, throw it all in the calculator. Okay, we know v of 1 is given, and this just goes straight to the calculator. And lastly, 92, that kind of jumps out at us. This function is given on which of the following intervals is g decreasing. So again, key calculus word. Got to have a game plan. How do I justify g is decreasing? You got it. There's our game plan. G prime is less than 0. So I need to go find g prime. So they give me g. This is that second fundamental. You take the upper bound and what do I do with that upper bound? Put it in first to any variable. So this is going to become the sine of x squared. And then I multiply by the what? Derivative of the upper bound. So times 1. And again, we spent almost 9 days as I went back and looked at that this afternoon. 9 days doing this. Plug in the upper bound, derivative of the upper bound. Obviously, you're going to set that equal to 0. It's graphing calculator. Look at the graph, and you want to see when it is less than 0. So use your calculator, look at the picture, and then you can figure out when it's less than 0. Okay, the questions that you'll see on these Grizzlies are all very similar in nature. They're not going to be the exact same, but they're similar. You need a game plan every time. Look for those key calculus words. Circle them, write a game plan down, and then attack based off that. So obviously I didn't go over every question, try to give you some tidbits. Hopefully your non-calculator section's almost done or is done. And then use 9th period or whatever to go through these. All right, we're going to jump back into our differential equations. And I'm going to jump to page 314. All right, we're going to tackle some slope fields. So what a slope field is, it's a graphical representation of a general solution to a differential equation. So we spent the past, last week, we did all those differential equations by hand, dy, dx, we separated the variables, integrated both sides, found the c value, etc. So now, this is the graphical version. This is what a slope field or a differential equation looks like graphically. Our general solution has an infinite amount of solutions, that's why we have this plus c, that are all parallel to each other. Okay, so again, there's this infinite amount of solutions that are parallel. So it might look something like this. We would say these parabolas are all parallel to each other. And really, this slope field is just a visual representation of our general solution to our differential equation. So there's a couple things they'll have you do with them, and we'll practice for the next few days here. One is literally just to sketch a solution in a function they already drew for you. So I'm going to find the point 0, -2. So just watch where they're labeled. They're not always labeled by 1s. 0, -2, plot my point. And now it's kind of just like driving. You're just going to follow the lines. You don't need to go hit every line. You're just going in that general direction. So if I go to the right, it looks like the flow of traffic. Is it going up or down? Down. So you're just going to kind of follow. It's almost like driving. Just follow the pattern. If I came from the left, so kind of picture coming this way, it looks like the pattern kind of goes like up, but then it kind of bends this way, like it kind of goes in this direction. Does that make sense? Kind of just following the flow of the arrows, or the line, so to speak. Okay. At -1.5, so that would be about here. Okay. If I kind of follow this one, again, I'm not staying on a line whatsoever. I'm just following the flow. Looks like it's kind of going up. And then this way kind of came in from this direction. Totally is. So we totally ignore what I just did. But yes, it is a -0.5. So let's go -1, -0.5. Yep. So again, something like this. Thank you. All right, 0, 1. All right, now this one's actually pretty unique. 0, 1, do you see how it kind of looks like a perfectly straight line to the right? It's not really bending. So this is very unique, and it looks like a perfectly straight line coming this way. This is kind of rare, but I think it's going to be very straight. Okay? Almost like everything is asymptotic to it, like it's getting close to it, but then it kind of like falls away to the other side. It's not actually touching it. So it looks like these kind of get close and then come this way. But that's a very unique where there's just a straight line. That doesn't happen very often. And then -1, +1 would be up here. And again, I think the flow of traffic is just kind of bringing me this way and kind of carrying down this way. So one thing I'm not sure if I mentioned, just make sure you go from end to end. Don't stop like halfway through the picture. Make sure you kind of carry it from end to end as you're going through. Okay. So we'll just try to follow the pattern here. So let's try number 2, 0, 1. So 0, 1 is here. It looks like for a split second it gets flat right there. Would you agree? Kind of has that flat slope. So I think as it goes this way and it comes up, it flattens right there for a second and then goes back up this way. And again, just follow the flow. Please don't try to hit every line. That's not the intent whatsoever. The only point you have to hit is the one that it says. And then 1, 0 would be here. Okay, so again, this way looks like it's going up. This way kind of eventually flattens right there and kind of comes down. And again, they're supposed to look semi-parallel to each other. Got a little hiccup in there. Let's take a look at this last one. -4, 4. I'm sorry, +4, -4. Here's 4. So again, they're labeled by 2s. Just be careful. +4, -4. So I would say it's kind of going up like that. 1, 0. All right, that looks like a unique one again. It looks to the right like it's very straight and to the left. So again, I think that's a very unique line where it's flat. It's very linear. And then 2, 2 out here. Okay, so this way it's going to kind of come down and hit. Kind of flattens out here. But now remember, this is like that asymptotic line because it's so linear. I think it's got to shoot. There's one little line that kind of tells me it's going to shoot back up. So our goal is just to kind of follow that flow of traffic. Let's try example 4 here, 0, 2. I think that's 1, 2. So right at 0, 2, it looks flat. This way it looks like it's coming up, but then it has to flatten there. Got a flat, and then these look like they're going down. Now what I notice is there isn't any slopes marked on my x-axis, so I'm just going to make sure I don't touch that x-axis because they don't know what the slopes are. There's no positive slope, negative slope, there's nothing there, so I'm not going to make sure I don't touch it whatsoever. Okay. And then in this example, you can just see like the true parallelism of all these general solutions. It looks like there's some asymptotic line here that they're not touching, and again, they're just getting closer and closer and not touching, just going through different solutions. So the next part is you have to be able to draw your own slope field, and this is in almost every free response question. The good news is they usually only have you graph like at most 8 points. Obviously, I put a lot on here just to practice, but there's never this many points to plot. So it's very simple. The only thing you have to be careful about is that you aim for something. So if the slope is 2, you got to make sure you really aim at a slope of 2. And I'll show you what I mean in a second. So we're just going to basically go to each point and plug these numbers in. And for the most part, you can do it in your head. If you have to jot something down, by all means, feel free to. But I'm going to start with 1, 0. Okay, so I'll write it down for a few times here. I'm going to plug in 1, 0. So my x is 1, my y is 0. I'm going to get negative 1 over 0. What type of slope is that? Does not exist. So it does not exist as a vertical line. So I'm going to just have a nice vertical line. I'm going to plug in 2, 0. So I'm just going to go this way. I'm going to get negative 2 over 0, which again does not exist. What's going to happen when I plug in 3, 0? Doesn't exist. There's usually a pattern you can start to see. Negative 1, 0. Yep, negative 2, 0, negative 3, 0. Now there's one hiccup here. What happens if I plug in 0, 0? I actually get indeterminate. There's no slope that's indeterminate. It's not undefined. It's not 0. There will be nothing there. They would never have you plot that. There wouldn't even be a point there on the graph, okay? So just make sure you don't plot any indeterminates. And then we just carry on. Let's go 1, 1. And again, if you can do this in your head, by all means do it. I'm just writing a few down. 1, 1 is going to get me a slope of negative 1. Okay, so this is what I mean by aiming at something. So here's my point where I'm going to draw negative 1. I want to rise 1, run 1. I want to aim at this dot when I draw it. So I just got to make sure I'm aiming at that dot. They're basically going to put like a plastic acetate sheet on yours, and it's got to match up perfectly. So aim at something. Okay. I'm going to go 2, 1. Okay, so this point, if I plug in a 2, 1, I'm going to get a slope of negative 2. So this time I'm going to aim at negative 2. So I'm going to rise 2, run 1. I'm going to aim at this point when I draw it. Okay. So my negative 2 slope better looks steeper than my negative 1 slope. If I plug in a 3, 1, I'm going to get a negative 3. So again, I'm going to rise 3, 1, 2, 3. I'm going to ballpark it up here, run 1. I'm going to aim way up there, and that should look steeper than my negative 2 slope. Right? A slope of 3 should look steeper than a slope of 2, should look steeper than a slope of 1. And then we just keep going. Like I said, there'll never be this many points. 1, 2, so I'm going to go to this point, 1, 2. If I plug in a 1, 2, I get a negative 1 half. So again, I'm gonna aim at something. I'm gonna go down 1 over 2. I'm gonna aim at this point when I draw it. Okay, so again, I'm shooting for a relative steepness. 2, 2 would get me a negative 1. So again, I'm gonna aim at a negative 1 when I draw it. And then 3, 2 would get me a negative 3 halves. So I'm going to go down 3 over 2 and kind of aim at that point over there. Just kind of draw a point where I think it's going to be and aim at it. Okay. Think you got the idea? All right, keep going, keep plugging them in, and we'll just try to fill that whole section in. So pick a point. And again, if you can do it in your head, you don't have to write them all down, but if you can do it in your head, that's great. keep going around and carefully plugging those points in. Watch that steepness. Always just keep making sure you're aiming at a particular slope. -1, should be -1. And you should start to see that they should be parallel. In this case, it looks like they're circles. Parallel circles of each other to get that general solution as you start to complete that diagram. But like I said, you'll never be asked to fill in so many points. 8's kind of like the most I've ever seen. But you're just going, if you have to write them out for yourself, by all means, go ahead. Some are easier than others. Some you'll start to see a different pattern too in the next couple examples. So flip the page. It'll give you a second to just go through these practice slope fields. You're just drawing in what you think is a solution. So I'll give you a minute to do that, and then we'll practice some more here. But take a minute and try to draw a sketch through each of those differential equations. there's one little hiccup in number 4 I just want to talk about. I don't think it popped up in our previous example. So if you take a look at this one, so like I said, walking around, everyone's done a great job there. When I plot 1, 1, what do you notice on the x-axis? Do you see any slopes here? So we don't actually know the slope. I don't think you can touch the x-axis. So I think this is coming down. And right about here, we have no idea what's going on here with these slopes. So we actually just want to put like an open, like I said, didn't happen before, an open circle saying, we have no idea what that slope is. We're just going to stop there. We're not going to go through it. I just don't think it's possible to continue that slope field here when we don't have any slopes on this x-axis. And then this one was perfectly fine, kind of going up like that. But I think this one's got to stop because we don't have enough information here to go further. Okay, and obviously I'm only keeping it on this side because that's where the point is. Okay. All right, so I've got a couple slope fields for you to practice on your own here. They have a lot of nice little patterns, you'll notice, because some of them only have X's or only Y's in it. So take a moment and tackle that one. It's real nice. There's only one variable. So we don't really care about the Y term in this case, right? Because there's no Y in here. So when X is 0, what is every slope going to be? 1. So at 0, everybody literally has a slope of 1. And just, again, make sure you aim at a slope of 1. They're all just going to be, the Y has no effect on it whatsoever because there's no Y in the problem. Okay, so just everybody at 0 has a slope of 1. Everybody at 1 should have a slope of 2. So it's really nice when there's only one variable involved. And just make sure you aim for a relative steepness. So that slope should look steeper. And then just kind of keep going through. -1, it looks like they're all zeros. So again, just watching that relative steepness as you go through. So we're going to finish that page for homework. Hopefully that doesn't take you more than 3 minutes a problem or so. But just take your time with those slope fields.